Lesson 3.6, Solving Inequalities Using Addition and Subtraction. Inequality is a statement formed by placing an inequality symbol between two expressions. Inequality symbols are greater than, less than, greater than or equal to, please write this down, and less than or equal to. The solution of an inequality is the set of numbers that make an inequality true when substituted for a variable in the inequality. Equivalent inequalities have the same solution. Example 1. Let's talk about graphing inequalities. A is greater than -6. First of all, the inequality tells you if it is open or closed circle. An open circle looks like a 0 and O not shaded in, where closed is a 0 and shaded in, or a circle shaded in. Open is when it's greater than or less than symbols. Closed is when it's greater than or equal to or less than or equal to. So that line underneath the inequality symbol tells you if it's closed or not. You can see for A, it's open, and the arrow, please write this down at the bottom, the arrow represents your variable. So we can see that A is greater than -6. So my arrow goes to the greater than numbers, which is to the right. The verbal phrase is all numbers greater than -6. B is a closed circle, so we shade it in. T is less than or equal to, so we go left. By the way, you don't have to make all the numbers on the number line. The way I like to make my inequalities is I'll just put 4, I'll put a closed circle, and then it's less than, so I go left, and really shade it in so you can tell which way my arrow is versus the number line. So you don't need to put all the other numbers on there, at least for me. C, x is greater than 0. It's open because there's no line underneath the inequality. X is greater, so you go right. All numbers greater than 0. That's how you could say that. Let's go the opposite way this time. You can see it's closed, and the arrow is at, well, first of all, the dot is at -2. It's closed, so I'm going to have the line underneath the inequality, and you can see Q is going to be greater than -2, so I go open up that way, towards the Q. Go ahead and practice graphing the inequalities. Remember, open is when it's greater than, less than. Closed circle is greater than or equal to, less than or equal to, and the arrow equals your variable. The variable is greater than or less than. Pause the video and graph the problems. Number 1. First of all, let's put a circle at 5. It's closed, so we shade it in. Y is greater, so we go right. Number 2, put a dot at 1. It's open, there's no line underneath the inequality. Now when we say this, let's say the variable first. N is less than 1. And again, you can write it this way if you want. See if it's a mirror image of the one on top. That's the same problem. So N is less than, which means you're going left. Oh, and I actually did mess up there. You can see that I put it at -1. Make sure that you put it at +1. And go left. 3 at -2.5, which is here. It's closed. P is less, so we go left. 4, -1.5, which is between -1 and 2, -2. It's open, Z is greater, we're going right. The addition and subtraction property of inequality says that when you add or subtract the same number on each side of an inequality, it produces an equivalent inequality. Let's show you an example of that. We're going to solve the inequality m minus 3 is less than 8. Instead of having the inequality symbol, think of it just as an equation. This is subtracting 3, which we changed to adding a negative. So to get rid of the -3, we add the opposite to both sides of the equal sign. The only difference is, instead of the equal sign that I'm going to bring down, I'm going to bring down my inequality. But it's solved the same as a one-step equation. Now we can graph it. Open at 11. M is less, so I'm going left. And please do not make this tiny arrow like this. If you have a whole graph, you need to show where the line is going. So you need to put the line all the way down to the end of the number line. Look at B. X minus 9, think of it as an equal sign if you need to, is greater than or equal to -14. We need to move the -9, which is adding a negative, so -9, the opposite is adding 9 to both sides. These 9's cancel to leave X. -14 plus 9 is -5. Please graph at 5, it's closed. X is greater, so I'm going left. And again, if you're making your own graph, you don't need to put all those numbers. You can simply do this. Just make sure I can really see which way your arrow is going. Part C, 6 plus A is greater than 13. Here is the 6 on the side with the variable. We need to clear. To get rid of +6, I add a negative or subtract. I like to say adding negatives, which gets 7 on that side. These cross off to leave A. A is greater than 7. 7 is open, A is greater, so we're going right. Please pause the video, solve the inequalities, and graph the solution. Number 5, change that to a -7. So to make -7 into 0, I add +7. That becomes 0. You're left with y. Bring down the inequality. -2 plus 7 is 5. Closed at 5. Y is less. I'm going left. Oops. I'll show you the answers at the end then. Number 6. Add a negative. Here's t plus -10. Add 10 to both sides. 14, inequality t. So at 14 we put a dot, it's open. And again, if you say the variable first, t, this is going greater than 14. So we're going right. Number 7, z plus 18 is the side we want to clear. So we add -18 or subtract. This is -3 is greater than or equal to z. -3 we put a dot and it's closed. Z is less than -3. We're going left. Number 8, we need to clear 7.5, 7 and 5/10 plus r. We subtract 7.5. I do like to say adding negative. We get r is greater than 4.5. Put a dot, it's open. Again, your dot should be right in between where the two lines meet at that intersection. R is greater, which is right. Let's check our answers. And again, it doesn't matter which way you put your answers for like number 6. You could have t is greater than 14. It is the exact same answer. Oh, and number 8, I did miss the negative. Make sure you always check that with your negatives, because that will lose you half credit. Should have realized that when I graphed. We are going to skip example 3.